Hey, this is Joe Burnett. I want to tell you about a project called Grit. This is the GitLab Runner Infrastructure Toolkit, and it's a library of Terraform templates. And what Grit is meant to do is it's meant to be a single entry point for deploying Runner. Everything from just a single instance to complex auto-scaling scenarios. It's meant to capture all the things, all the best practices that you have to learn that we have experience with from running runners on GitLab.com. It's meant to be easy to address the needs that you want as they get more mature. So you can just say very simply what you want and get the runner up and running fast. It's also meant to cover the life cycle of runners so you can continue to upgrade it over time. Terraform is a really good tool for this. So this is provided as a Terraform library. So let me show you what it's like to use Grit. So I'm going to do a demo. I'm going to show you setting up a simple runner. I'm going to show you setting up a more complex runner. Then I'm going to show you how it's used for development. And then after that demo, I'm going to tell you a little bit about what Grit can do for the various personas and use cases that GitLab Runner has. So you can see what it does, what it can do for you, and the value that it adds. Yeah, so let's get started. All right, so here we are. This is my Hello Runner project. All it does is it just says Hello Runner, very simple. And right now, it doesn't have any project runners associated with it. And I've turned off shared runners. So right now, it can't do anything, okay? What I want to do is I want to put a really simple runner on it. So I'm going to come over to Grit, okay? And here I've put this code here inside the Hello Runner project, but it could live somewhere else. You might have a single repository where you manage all of your infrastructure. But here I have this this little folder in Hello Runner where I keep my Terraform code, and I've created a module called My Little Runner. And what it does is it imports Grit, specifically the test environment of Grit. And I'll tell you in a few minutes what that actually means. And I've parameterized it with the things that I actually care about. I want to run my my instance, my runner manager on EC2. Okay, I just want to make a really simple EC2 instance. I don't want it to have its own capacity for auto scaling. Like sometimes you can make a runner manager, but you can also give it like a pool of VMs or a cluster or something to do the actual jobs. But I don't want that. I just want it to run it right there. This is the project ID for Hello Runner, and I just want you to attach it there, please. Call it this and run jobs that are tagged with that. And that's kind of just about it for the description. Terraform's a infrastructure as code system. You describe what you want. Here underneath the hood, it uses Terraform to do all of these things, but it just brings it to a single module that is very simple to configure. So here I am. You can see I have a few things here. I've put my secrets in Terraform, TF-vars, but other than that, it's quite simple. So the first thing you do with Terraform is you initialize it. It's just going to make sure it has all the providers, right? Because for all these different things, Google, AWS, Azure, Kubernetes, Helm, all those things, it has providers that know how to make these things happen. And Grit actually uses all of those for all the different ways you might want to deploy Runner. If you want to put it on EC2, Azure, GCP, if you want to put it in a Kubernetes cluster here or there, deploy it with the operator, with Helm. It's meant to address all those use cases in this very simple declarative way. So, all right, we're initialized. That's super great. I'm going to apply this little template here. And it's going to tell me, I want to add 8 things. Is that okay? What are you going to add? You always review these plans. That's an important step, as you operate this stuff. You just take a look at it and see. It actually compared the real world to my desired state. So it actually went to AWS and said, I'm supposed to have an instance. Do I have an instance? No. Okay, I better add it. So it's going to create an instance. It's going to create an internet gateway, routing table, just a bunch of stuff, security groups so I can SSH to it, a subnet, VPC, etc., some credentials, whatever. All right, so I'm going to say yes, and it's going to go create this stuff. Super. So at this point, it just kind of runs, right? And it's going to store references to all the stuff that it created and the outputs and all that in what's called a Terraform state file. You never check that into your repository because it could have secrets in it. So I've told my project to ignore it in git ignore, but GitLab does support natively putting your Terraform state in GitLab. It'll store it for you. So this is how like our SREs manage all of our infrastructure. They have Terraform, doing all this, storing the state in GitLab itself, so you can just rerun it as part of a workflow. It's already created this stuff. It's going to take a few minutes to boot up because I told it to install, like it's a reference to the generic Linux AMI, so it's going to install runner, get it registered and all that in the background here. So in the meantime, let me just show you real quick what is actually going on here. So I'm pulling in test. Well, what is test? Let's take a look here. So test is, let's just go up, and I've put grit in a sibling folder here. It will be published, so you'll be able to pull it down and reference a specific version. But in test, there's this file called test Terraform. And it has quite a few things configured. GitLab registration is done in here. So basically it takes the output of this setup and it actually registers a new runner, takes that token, injects it into the VM and says, hey, here's your token, and then connects the two. It can also create Kubernetes clusters, GKE, EKS, AKS, whatever you need. Now, these little blocks here are sort of the weird Terraform way of doing a conditional. So it's not going to create a GKE cluster unless you want to run jobs on GKE, or if you want to have your runner manager on GKE. It'll just skip it otherwise. As you could see, I didn't make a GKE cluster. Same with instance groups for fleeting. Like this, you'll notice that this uses an internal fleeting library to create the actual fleet, take those credentials, plug them into the runner. Same thing with runner manager. You can run those as VMs in GCE, EC2, Azure. You can have your runner manager in Kubernetes in Helm or the operator, and all of that sort of flows outwards from those initial parameters. So if you look at these variables here, there's not a lot. There's a couple things you must provide, right? You must provide, the two, capacity parameters. Tell it where you want to put it, right? Because we're registering a runner here. It'll default to gitlab.com. It'll have, by default, it'll run untagged jobs, and it'll give it a default description, but you probably want to put something a little bit more useful to yourself. Let's take a quick check and see if this thing is up and running. Let's refresh here. How are you? Oh, so I made the runner, but it hasn't contacted me yet. So that means that it's still installing runner on that VM. So I'll show you a little bit more here. All right, so how did that installation happen? Well, if you look here, if you look here, under the EC2 managers, we actually import from internal manager EC2. And what this does is it makes that AMI, all that stuff that I was making is here. And when it makes the actual AWS instance, it uses user data. So under the hood, this thing uses cloud init to do the installation. And it just parameterizes the template with the URL and the token, all the stuff that you usually need for registration. And the cloud init configuration is here in the same folder. It's quite simple, just make some users that we need, install our dependencies, and these are all just basically the instructions from, installing from the Linux repository. Do the thing, and then register it with the URL and the token. And that's it. So you can inject other parameters here too. Over time, this will evolve. It'll get, be able to service all the use cases. But that's really all it takes to get a runner up and started in EC2. Let's have a quick look again. Are we here? We are. Super duper. So it's actually running on an EC2 instance. So if I come over here and if I refresh, you can see I have my test instance here. It's registered. It's ready to run jobs that are tagged with the tag that I asked it to do. So that's great. That kind of gets you, that's like the real entry level requirement. Now I want to show you something maybe a little bit more complicated. Okay, so here, I'm going to come over to, I'm going to come back to my little module that I made, and I'm going to add a runner. So I'm going to pull up my handy scratch pad here, and I am going to make a runner that operates on GKE. So here, this looks pretty much the same, right? I'm using the same test framework and all the guarantees and defaults that it has. And I'm going to use instead Helm. So I'm going to say, all right, my runner manager is going to be provided by Helm. And it's going to install it wherever I give you credentials for, right? And the capacity that I want to provide is GKE. So now it's going to create a GKE cluster. And these others are pretty much the same, right? Same project, please, different tag, different name, just for my own purposes. So this little runner, it used AWS credentials. But it was the AWS provider was able to like go find them in my home folder. The Google provider wants them more explicitly. So, and the Helm provider needs credentials too. Like the Helm provider has no idea where my cluster is. So I actually need to come down here and configure these providers. So I'm going to grab that. And I'm going to, in this providers folder, notice actually, one provider I did already give credentials to was GitLab, right? Because I needed to give it my personal access token that I put in that secrets file. With Google's actually able to find the credentials itself, but it does want me to tell it what project to put it in. And then for Helm, I need to tell it, okay, and you are going to get your credentials from that cluster that I just created. So I reference my GKE cluster with the host, the access token, and the certificate, and give it to Helm. So now Helm can do anything. And what Terraform does is it figures out the right order to apply these in. So it's going to set up that cluster. It's going to extract those outputs, give them to the Helm provider, and then all of those Helm resources, which is the runner installation, will be free to be created. Okay, so I've got this, make sure all my files are saved. Okay, and we're going to come over here and we're going to do another Terraform init, all right? Because I think that there's a few more providers that we need to have. Terraform init. Blah, blah, blah. Okay, apply. Let's make some stuff. What are you going to make? Here's the plan. And you can actually just run Terraform plan and it'll give you this without asking you if you want to apply it. And you can even save it to a file so that if anything changes underneath you, you won't do anything unexpected, like create a resource you don't expect, right? Like if this is, again, comparing my desired state to the real world. So it actually went and talked to GKE to check to see if these things exist. And they don't. If somebody changed the file underneath me, I might create something I don't expect. So you can save these plans too. Anyway, it's going to create, you can see it's going to create a Helm release. That's expected. It's going to create a node pool. That's super great. A cluster subnetwork. It's going to create a user. Sure, whatever. I'm going to say yes. This is going to take a little bit because it has to create the GKE cluster, which can take a long time, and it has to create a bunch of other resources. I don't have anything to do, right? Like at this point, I'm just sort of, I can go do something else and I'll come back and all this will be set up. So I'm going to go have some grits. I'll be back in a few minutes and show you what we've created. Oh, okay, I'm back. What do we have? A bowl of grits. They're absolutely delicious and nutritious and very good for a day you want to go for a run. Easy to make. What can I say? Anyway, getting back to this cluster, it looks like it's finished. So we made the cluster, made the node pool, made the Helm release. Super. All right. So let's go take a look and see what we have. Here I am back at my runner project. And I'm going to refresh it. We have a new GKE runner and it's registered. So let's go take a look and see if these resources are actually there. Here's my sandbox project. And there it is. We actually have a grit cluster, 2 nodes, super workloads. We have a runner. That's pretty great. All right, let's try it out. Let's actually see if this thing works. All right, so I'm going to come here to the repository. I want to show you the job we're about to run. We've got 2 jobs defined here: hello little runner and GKE runner. One's tagged with a little job, one's tagged with the Kate's job. Because if you remember over here, we told them to run those respectively, Kate's and little jobs. Super duper. Okay, let's run this pipeline and let's see what happens. Come over here, run the pipeline, la la la. Okay. You gonna run? I hope it runs. You gonna run? Let's come back here. Oh, whoa. All right, little runner already picked it up. Hello, little runner, super duper. It ran on this. This is definitely an AWS. Great. So if you look, if I was to SSH into that little instance, I would see in the logs that it actually ran that job. And what about GKE? What are you doing? Oh, whoa, it's done already. All right, so it made its own pod, and it ran right there at GKE. So if I actually come over here to workloads, I would have seen a pod. It's gone already, but I can actually look at the logs and actually see that it finished processing the logs. It's a little weird that all those are like error logs, but whatever. Anyway, it finished the job. Super duper. So that's it. I just added 2 very different kinds of runners to my project, was able to run them both. And you can evolve the structure this way too. You can change parameters, etc. All right, so that's kind of like the test module that I imported is a complete setup. And it's one with a whole bunch of defaults that just make stuff work. So you can, this is really useful for like end-to-end tests, kicking the tires, demos, stuff like that, getting things up and running really fast. There's also a use case for development. So like as you're working on the runner code, maybe you want a stack of Macs to work on, but they're really complicated to set up. This is something that I encountered quite a bit working on runners, on Mac runners on AWS. So there's another module here called tests, or called dev. And I'm going to reach into my bag of tricks here and pull out another module, and I'm going to call it my experimental Mac machines. But you'll notice this one looks a little bit different. First of all, I'm importing the dev. And dev doesn't actually build a complete stack. It builds pieces of the stack, the pieces that you're not working on so you can focus on the part that you want to. So in this case, I'm asking for an EC2 fleeting provider. Now, fleeting is this Docker machine replacement. It puts all of the capacity behind an interface that lets you just treat it as an instance group, whether it's AWS, Azure, or GCP, or any plugin. You can really put any capacity behind it. You just say how many instances you want and get connection info to them. So it needs credentials, right? It needs SSH credentials to get to it. It needs credentials to scale it, etc. Those are what the outputs are here. And specifically, I want macOS. So here, I created this thing. Remember, it already has access to AWS, so that the provider already knows what to do. So I'm going to do my init again. Just make sure that it's ready to go. And I'm going to apply, and it's going to create something. It's actually going to create a lot of stuff. A Mac setup, like what we have on GitLab.com, is really complicated because Macs in AWS are dedicated machines, but they're slow to come and go. So we need to run VMs inside of them. So we actually have a special agent that we install called nesting that starts and stops VMs where we run the jobs. Additionally, not only do you need dedicated hosts, like you need to create and remove dedicated hosts, you also need to create the instances that go on those hosts and say, please schedule these on here. And in order to wire all that together, you need to have a license, a custom license, and some provider stuff. I can't remember. I set it up in Terraform, but I don't really need to remember unless I need to work on it. So all this gets set up for me automatically. 15 things to add. I'm going to say yes. It's going to work away. I'm going to show you a little bit about what's inside dev. So we're going to go under here, back to Grit. And instead of test, we're going to go in here to dev. And when we look at dev, it's a little bit more simple, right? There's not a whole lot that is in here yet. We'll just put whatever we need in here, depending on what developers need. And in this case, you know, it sets up various fleeting providers for you. And here I've used EC2. Now you notice Mac's not here, right? This is set up in sort of like a hierarchy. So there is a kind of an explosion of possibilities, but it's all managed in a way, it's decomposed in a way that you don't have to repeat yourself. So at each level, you have a different decision to make. So if I look underneath here, like you'll see that it's importing the EC2 module. If I look under EC2, now this is where I decide what operating system. And again, we go deeper, Mac OS, and here's where we actually make the stuff. Now, you'll notice that in this tree here, we're under these modules that I import, right? This is the public interface. This is what users of Grit will be able to do. And it's well-defined. There's promises about how things will change. But now it's going to use some of the internal implementation details. Why? It's because the test structure here, this test module, comes with a bunch of defaults, right? It's not going to make you make a bunch of decisions. It even has a default AMI, right? Like the point is to get it up and running. In production, you're going to want to configure your own AMI, your own subnets, stuff like that, maybe even your own instance types. So if you follow the same tree in production, it's going to import the same library, internal library, but it's going to have fewer parameters. So yeah, it uses this internal fleeting library here. I'm going to go load that. Fleeting, EC2, macOS, and you'll see there's actually a lot more there. There's all that stuff that I was talking about, the license manager, auto scaling groups, service accounts, keys, all the networking stuff gets set up there. And what it actually outputs is those credentials I was describing, the key, access to it, auto scaling group names, stuff like that. And those get bubbled all the way back up to the module through maps where you can output them. So you can reference them. Same way, you know, the Helm provider was referencing the GK cluster. You can ultimately reference anything inside of this that you created. So that's super great. You can see it created it. Now, at this point, what I would do as a developer is I would go into GitLab Runner code, use these credentials that are the outputs, give them to put them in files, start GitLab Runner, point it to my instance, and then just do whatever it is I want to do. And there's actually my own dedicated capacity there that auto scales just like production. So that's the dev thing. But I'm kind of done with the demo. So I'm going to do some cleanup. So I can just destroy everything here. It's very satisfying. It's going to look at the state of the world, and it has its own internal state, and it's going to say, I need to do all of these things, destroy 29 things. I'll say yes, and I'll let that just go to 10. All right, so that's the end of the demo. At this point, I want to just kind of talk to you about the values and the use cases of Grit. So Everything I'm about to tell you is on the README page. The URL, it's under Runner Tools, under Grit. So I'll put a link to Grit in the description of this video so you can find it too. And all this stuff, like these the examples that I just showed, are in the README, as well as everything that I'm about to tell you. So what can you, what kind of value does this add? Like this is pretty cool for a demo, right? And it's nice clearly for development, but what else does it do? So yeah, you can set up demos easy. You can have and it also provides a single entry point for discovering and learning about runner configuration. Like you can come here to Grit and it will point you in the right direction, even if that direction is using maybe a different tool. For example, there's the AWS vending machine, which has very well-informed best practice templates for setting up runner on AWS specifically. And so if we want to use those, if those are like the best thing to do for AWS, you still come to Grit, and Grit can create a Terraform template. As a matter of fact, we do that for some of the resources under the hood. So the point is give users fewer choices about where to start because it's confusing. Start with Grit. It will guide you. It also gives you a common test library that verifies that we don't break users' infrastructure. So when people use Grit in their production infrastructure and we test with Grit, when they use prod and we use test to test it, we're under the hood using the same library, and we can verify with higher confidence that we're not going to break user infrastructure. So that's the testing part of it. Development-wise, it's easier to develop. It's also easier to reproduce bugs that you have. So a user says, hey, I've got a problem. My Macs keep, crashing every 10 minutes. Well, I can reproduce their setup quite easily. If they tell me the version of Grit they're on and what parameters they're using, I can set up a stack just like it, a stack just like production in the same way, whether it's, SaaS or whether it's self-hosted, and work on reproducing that. Because, there's so many different ways to set up runner, it's hard to reproduce issues. In production, it takes GitLab SaaS runners and makes them more transparent. We plan to use this in production. So right now, we already have Terraform templates. Of course, we're using this because it's the best tool, but the templates that run our SaaS runners are not really architected in a way to be reusable. So over time, we're gonna start migrating. So we're dog fooding Grit. So ultimately we'll be using Grit as well. And then when you look at SaaS runners, you know exactly what's happening, under the hood, what it is that we're doing. It just makes it transparent. It also makes it so that users can contribute back. Like if somebody says, oh man, Mac runners are slow. I'll bet you if they use this different, super duper, SSD type, it would make it better. Well, they can actually spin up a stack that's identical to ours, tweak a parameter, show the test results, and send that with the MR. And they can actually contribute back to runner SaaS, which is something that we haven't been able to do before. It's also, Grit is going to power dedicated runners. So dedicated runners is where it's just like dedicated GitLab. You can get your own dedicated stack, but there's a higher level control plane that's stamping these things out, right? Well, we want to put runners on it. So it's going to stamp them out with Grit. So right now, in the 16.5 iteration or current iteration, one of our P2s is to create a production-ready template, our first Grit production-ready template for that specific use case so that they can roll out runners at will. And this will ultimately be also the way that runners are deployed in GitLab cells, which is the future of scalability of GitLab.com. So it has a lot to give for production. For self-hosted users, it allows, if somebody is just simply not using our SaaS, if they want to if they have, for whatever reason, they need to manage their own infrastructure, if they can use a public cloud, and if they have a use case that's supported by our templates, they could just get the benefit of best practices, like the things that we know that we do in production for ourselves because we've learned, they can automatically roll that out. And we can also learn from them. So like if there's something that they do that we haven't yet learned, they can also contribute that back in a way that's compatible. There's a very wide reach to Grit. When we have a regular cadence of release and upgrade, best practices, bug fixes can just kind of roll out widely. Like even a self-hosted customer can benefit from a bug fix that we did on SaaS through, releasing Grit every iteration and having sort of a planned upgrade process, which we can test. Also, it makes it a little easier for those support issues. When a user says, I'm seeing something, they can say, I'm on Grit, 16.5, and I've got these parameters, and support will know how they're configured. So even like even before it gets to like reproducing a bug, they can be like, oh, I see that you've done this. I'm familiar with that setup. I can even reproduce that setup. I can see how it's created. So let me tell you what to do if you want to accomplish A, B, or C. So that's the value. That's the value that it can provide. Now, this is infrastructure as a library, right? Like that's the Grit approach. Is it's like giving you this library, and it needs to have very clear promises about what it will and what it won't do. So the API is defined in those module dev, test, and prod folders. And the API is the parameters that you take in, the things that I was changing. All the dev and the test ones can change pretty easily because the guarantee is not really much. Test should work, right? All those templates will work and register something that operates, but we'll change it, as we move along. The prod stage, however, is going to have each template, each use case is going to have a maturity associated with it. Alpha, beta are stable, right? Just to kind of indicate where that particular use case is at. So for example, as we're coding the GitLab dedicated use case or the dedicated runners use case, we'll create a template that works for them to try out, but it'll be alpha, and then it'll be beta when we think it's ready. And when a prod template is stable, we'll provide specific guarantees, like it won't create any unnecessary infrastructure destruction. So like if you, for example, refactor the Terraform code, that can result in one instance group getting destroyed and another instance group getting created if Terraform sees them as different things. That's not desirable for a stable production template. So what we'll do is we'll test for that. And if a template is stable, we'll assert that like any upgrades don't actually destroy anything. And there's specific ways in Terraform you can refactor without having those destroyed. And if we need to do something that's a breaking change, we'll message that appropriately. So yeah, that's kind of like all this is laid out again in the README and the Grit repository, which I'll link in the description. Grit is available for contribution. Structures there. There's a whole section on like how to do it. Link for best practices for Terraform. At this point, it's really going to be driven by whatever people want to do with it. So it's going to, it has a huge space that it can cover, but we're just going to one by one do specific use cases. So yeah, go take a look at it, try it out. If you want to try to make your runner deployments easier and you're willing to use Terraform, give it a try and contribute back. So thanks a lot for listening. Thanks for watching, and I hope you enjoy it.